Hey y'all, this should be a pretty quick video on distribution shapes. So it's kind of a continuation of my organizing data video, and hopefully my dog does not act up in this video like he did in the last one. So I'm very sorry about that distraction, but dogs will be dogs. You'll have noticed in my last video, if you watched it, that I kept tilting my head to look at the shape like this of the data. That's basically leading into distribution shapes. Excuse me. I think you can probably hear my dog chewing on a bone. Now, that's how I got him to behave. I gave him what he wanted, right? That's good discipline. It's not. Don't do that. Okay. So before we get into distribution shapes, we need to know what mode is. Mode is the value or observation that occurs most often. So sometimes there might be multiple modes or no modes or one mode, and that kind of plays into the next thing. Unimodal, a unimodal graph has one peak. A bimodal graph has, guess it, bimodal means two, and multimodal has three or more. So look at these sketches below and decide which one is unimodal, bimodal, and multimodal. Pause it, try it, come back. This one is unimodal, bimodal, kind of in order. Whoops. Multimodal. Multimodal. Remember that commercial? Never mind. Forget it. There are three categories of symmetric distributions. There's bell-shaped, triangle-shaped, and rectangle-shaped. And that's kind of a sketch as to what they look like. You're going to see this one a lot. And sometimes distributions are not symmetric. They might be right or left skewed. And this is important. It does matter which one is which. A right skewed has a right tail, and a left skewed has a left tail. So we call these tails. And we're going to look at the next pictures on the next page and decide if they're symmetric, right skewed, or left skewed. And then we're basically done, which is nice. So take a look at these and decide, let me make it smaller, which one is which, and then draw one of your own, a uniform or rectangular distribution. Pause it, try it, come back. This one, if you kind of sketch, has a right tail, so it is right skewed. This one, if you kind of sketch that, has a bell shape, so it is symmetric. And then the last one has a left tail, so it is left skewed. Easy, right? And if you were to just sketch, this is going to be a rough sketch of a uniform distribution. Just has, they're all the same. So like each one of these values occurred the same number of times. That's all that means. That's a really bad picture, but you get the idea. And then in this next one, I want to talk about the mean and the median, but we haven't actually learned that yet. So I gave it to you here because it is important and I want to talk about it with respect to distribution shape. So This is the data. I want you to look at it and decide if you think it's left skewed or right skewed or symmetric. And then I've given you the mean and the median, and I want you to note what type of skewed distribution shape it is and how that relates to the mean and the median. So pause it, think about it, come back. If you tilt your head and you kind of draw that, that is a right. Actually, I'm going to circle right. And if we look at the mean and the median in a right skewed graph or distribution, sorry. See if I can zoom in on that a little bit better. Right skewed distributions. I am going to write that, but I need to write it smaller because I've run out of room. Sorry. Right skewed distributions have a mean greater than the median. Oh, still ran out of room. You learn it better when you write it multiple times, so I am getting this. Mean greater than the median. Okay, so the mean pulls, it skews that data. You can kind of think of it, it pulls that tail to the right because it's larger. So it means you have maybe an outlier that's larger than the rest of your data, which skews your data. And if we were talking about left skewed, the median would be greater than the mean. Actually, I'm going to rewrite that. That is a true statement, but I'm going to rewrite it with mean on the left side. Mean would be less than the median. So your outlier would instead be smaller than the rest of your data, and it's going to pull that tail to the left. Isn't that neat? One more. Almost. One more. So when you describe a distribution, and a lot of this stuff we have not learned yet, so you can't actually use it yet. You could use general words to describe it, but when you describe a distribution, you need to talk about the center, the spread, the shape, which your options for shape are symmetric, skewed right, or skewed left, and any outliers. So we haven't actually learned about center or spread. Center is what you would think of, the middle, and spread means like how stretched out it is. Is all your data get clustered up in here towards the middle or over here, or is it spread out? And then the shape refers to like that bell shape, or if it's skewed, or if it's uniform, and then any outliers that might occur or might be there exist, is what I'm trying to say. Outliers that might exist, and we will also learn later in this semester how to determine if an observation is an outlier or not. And then don't forget that when you're drawing your graphs to label, so that you are very specific. You don't want to leave anything for question. Okay, that is all. That's it for this video. I hope you enjoyed it. If you have any questions, let me know and I'd be happy to help.